Hello, everyone. I'm sorry that I have to be gone today, but I have to attend a meeting. And so we're going to continue onwards anyway. Last lesson, we completed section 3.5, day 1, which was on finding the slope of lines given a variety of information. Sometimes we were given a table, sometimes we were given a graph, sometimes we were just given 2 points and asked to find the line or the slope of the line that would connect those 2 points. So if you would please start by having out your homework for that lesson. It was for section 3.5, day 1. It was for day 7 on our assignment sheet. It's the assignment that started with problems 1, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then finished with 14. So if we need to pause the video now to make sure everyone has their homework out and ready so that we can read off the answers, you can correct yours and then circle any ones that you have a question on when you return. So pause the video now if we need to, otherwise I'm going to assume that we are ready. Question number 1, the word of the day was slope. Problem 5, it has a negative slope. It is going down 3 and right 5 when you calculate the slope. 6 is a positive slope. It's going up 4 and right 3. Question 7 is a horizontal line. That is a 0 slope. Question 8 is a negative slope. It's negative 4 over 5, so down 4 and right 5. Question 9 is a positive slope of up 1, right 2. 10 has a slope of 0. That's a horizontal line. Question 11 is an undefined slope. That's for a vertical line. Question 12, slope's negative 7, or the value is negative 7. 13, m, the slope is 60, meaning the bus is traveling at 60 miles per hour. Question 14, the slope is 0, meaning the admission fee does not change based on how long you've spent in the park. So those are the answers for 3.5, day 1, day 7 in our assignment sheet. So correct it, and I will check it when I return. At the bottom of that assignment, I would like you to try a few warm-up questions. So at the bottom of that assignment, I would like you to try these 2 warm-up questions. First one is just a review from that section that we just covered. Can you find the slope of the line that goes through the point negative 5, 6 and 0, 8? You're going to be using the slope formula that we talked about on Friday, finding the rise and dividing it by the run. The rise is the difference in the y's. The run is the difference in the x values. And then question 2, a review question. Can you find the x and y intercept for the equation of the line that is 8x minus 5y equals 80? Can you find what the x and y intercept is? And for that, you're probably going to use a little 2-point table because you're finding 2 points, the x and the y intercepts. So pause the video now for maybe a minute. Unpause it once everyone's had a chance to try these warm-up questions. Okay, let's go over question number 1. You should probably label the coordinates. This is the x coordinate of the first point. This is the y coordinate of the first point. This is the x coordinate of the second point. This is the y coordinate of the second point. Now you know what to substitute in. In for y2, you're going to be putting, so we'll say slope is equal to y2, which is 8, minus y1, which is 6, being divided by x2, which is a 0, minus x1, which is a negative 5. So you're going to be subtracting a negative. 8 minus 6 is 2. 0 minus a negative 5 is 0, plus 5 is 5. So the slope of the line that would connect those 2 points is going up 2 and right 5. So its slope would look something like that, where it'd be going up 2 and it'd be going right 5. Question 2, in order to find the x and y intercepts, you need to use the fact that if you're trying to find the x-intercept, your y-coordinate is 0. If you put 0 in for y here, that equation just becomes 8x equals 80. If you divide by 8, you'll find your x-intercept is the point 10. If you want to find your y-intercept, you put 0 in for x. If you put 0 in for x, this equation now becomes negative 5y equals 80. If you divide by a negative 5, you'll get negative 16. Then if you have 2 points, you could graph it. Your x is over here at 10. Your y-intercept, it would be down here at negative 16, and you would draw in the line between those to graph it. That is how you graph a line in what's called standard form. Standard form is when x and y are on the same side. You graph by using intercepts. So those are the 2 review questions for the day. You now need your note packet out to section 3.5, day 2. If you're following along in the note pack, which you all should be, it would be section 3.5, day 2, which in the note packet is just going to say 3.5 slope intercept form day 1. It's the second day that we're doing 3.5. but it's the first day that we're doing what's called slope-intercept form. So in the note packet, it should say 3.5 slope-intercept form day 1. That's the one you're looking for. And it's going to start with actually this question. So far we have two ways that we can graph lines. You can make a table, or you can find the x and y intercepts, which is exactly what we did here in the warm-up question 2. Finding x and y intercepts is only going to be helpful if your x and y are on the same side of the equation. If you look here, it is not. So what we're going to do is we're going to go back to our very first tool when we made tables, and we're going to pick out a pattern that was there all along, so we don't need to make a whole table in order to graph lines anymore. We're going to try to self-discover a shortcut, if you will. So recall, when we made tables before, unless it says like x equals a number, I can pick my x values. And this equation right here does not say x equals a number, so I can pick my x values, and the easiest ones to pick are probably 0, 1, 2, and 3. So fill those in for your x values, and then what we're going to do is we're going to substitute them in one at a time. If I put 0 in for x, my equation becomes y equals 5 plus 2 times 0. 2 times 0 is 0, and 0 plus 5 is 5. Then I'm going to put 1 in for x, and my equation would then become y equals 5 plus 2 times 1, which is going to be 7. If you put 2 in for x, 2 times 2 is 4, and 4 plus 5 is 9. If you put 3 in for x, 2 times 3 is 6, and 6 plus 5 is 11. You would then take these points and plot them. So this would be the point 0, 5, right there. This would be the point 1, 7, then 2, 9, 3, 11. And with that, you would then sketch in your line. So that's how we did it before, but now let's try to pick out how I could actually have graphed this equation without making the table. We're trying to see how can I go from here to here in one step. Well, let's look. The first value is y equals 5. Where does that occur in the table? It's the very first point that I get in my table. On the graph, it's the y-intercept. So this very first number that's all by itself in the equation is going to be my y-intercept. So we just found that that is the y-intercept. The y-intercept is the point 0, 5. It's the number all by itself in the equation. Now let's see, what does the 2 do in the table? Well, in the table, it's telling you how your y's are changing. It's saying go up 2, go up 2, go up 2. Where does this 2 occur in the graph? This 2 is the slope. It's saying go up 2 over 1, go up 2, and then go over 1. So this number right here that's next to the x, that is the slope. We use the variable m for slope because the mathematician who first developed it thought it reminded him of mountain slopes. So m slope is equal to 2, which is 2 over 1 in my equation. So the shortcut that we can start to self-discover is the number all by itself is the y-intercept. The number next to x is going to be the slope of the line. So I don't need to make a table every time. We're going to see if that's true one more time. So we're going to make one more table, see if that property still holds. And then going forward, we're going to use this shortcut that we've just self-discovered. So again, if I graph by making a whole table, I'd probably start with the x values of 0, 1, 2, and 3, and I'd fill them in. If I put 0 in for x, I would have y equals 3 plus 0. And 3 plus 0 is obviously 3. If I then put 1 in for x, I would have y equals 3 plus 1, and 3 plus 1 is obviously 4. Then if I put 2 in, I get 5. If I put 3 in, I get 6. I then plot these points. 0, 3, 1, 4, 2, 5, 3, 6. I'd have my line, and I would graph it in. That's how we did it in the past when we made a full-on table. What would the shortcut be now? Well, this where it says y equals 3, this 3 that's all by itself, if I look in my table, it's the y-intercept. It's the y-intercept because it's the y value when x is 0. I can see it's the y-intercept because I can look at the graph and see it's where it crosses on the y-axis. So my y-intercept is that value 0, 3. Now, what number is in front of the x? Well, in the last one, it was obviously a 2. In this one, there is a number in front of x. It's just not explicitly written, but it's a 1. Where does that 1 show up in my table? Well, it's how my y's are changing every single time my x's go up by 1. Well, that's plus 1, plus 1, plus 1. That's my slope. If I look at my graphed line, I see the slope of it is Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. That's the slope. My y's are changing by 1 and my x's are changing by 1. That means my slope is equal to 1 over 1. So the number in front of x is the slope. The number all by itself is my y-intercept. That form we have a very special name for in math. It's probably the most famous equation for a line. It's called slope-intercept form. The reason that it's called slope-intercept form is because the form tells you just by looking at it what the slope and the y-intercept are. For this example right here, if I have the equation y equals 1 over 3x plus 1, I see that my y-intercept would be 1. That's this point right here. And the fact that this number is 1/3 in front of x tells me that my line goes up 1 and over 3. My y's go up 1 for every 3 that my x's go over. I should note, though, that the order in which these are written is not important. This could be written as y equals 1 plus 1/3 x, and it would be the exact same equation. The order doesn't matter. The number all by itself is the y-intercept. The number with the x, or in front of the x, is going to be the slope. That's why I think it's probably easier when first learning it to write it as y equals b plus mx. However, the rest of the world writes it as y equals mx plus b. Good question is, why is the y-intercept called b? Well, it's because the original form of the equation, please stop it. Okay, the original form of the equation was y equals a x plus b, but then the mathematician who first worked with these changed this a to be an m because he realized it was the slope of the equation, and the slope reminded him of mountain slopes. That's why the y-intercept stuck as the value of b. It used to be ax plus b, but then it got changed to mx plus b. I want to show you how you can graph these actually in your graphing calculator. So have your graphing calculator out, turn it on, and we're going to type in some equations. Just to show you that this is a graphing calculator, it can graph lines for you so you can check your work. So it'll take a second for mine to boot up. We're actually going to be using the graphing feature for the first time ever. So if you have a weird screen up, you can quit that by hitting second, and then it looks like you're hitting mode, but you're really hitting quit. Now you're back to the calculator screen. You can clear it by hitting the clear button. Now you're going to go up to y equals. And if there are equations in there, you can just clear them out. Just hit clear, hit clear, hit clear. And let's type in some of them. So let's type in the first 2. So this is y equals, the 1 just means the first equation, 2, and then the x variable is right here, just to next of alpha, 2x. Let's do plus 3. Then go down to the next one, type in 2x minus 4. With those two, then if you want to see them, you hit the graph button. If you have a weird window, you might need to hit zoom first and then reset it with option 6 to zoom standard if somebody's messed with your window. Or you can just say graph, and it will graph our 2 lines. I'll see that one that was starting at 3 is starting at a y-intercept of 3, and the slope is up 2, right 1, up 2, right 1. This one starts at -4 and goes up 2, right 1. You'll see that these 2 lines are parallel because their equations have the same slope. So there's how you can type equations into the calculator. I want to show you one last thing before we do a few more practice problems. Just to show you how y equals mx plus b works. Over here in Desmos, I can change the slope. So if I increase the slope, like to 4, it'll make it steeper. If my slope is 0, it's a horizontal line. If my slope is negative, it goes downward. And then if I change the b value, all that does is change my y-intercept, changes this point right here. So right now, b is set to be 5.5. If b goes to negative, then my y-intercept is negative. So that's how slope-intercept form works. First thing that we're going to do is just practice picking out information. So if I give you the following equation, can you pick out the slope and the y-intercept and graph the line without needing to make a table? So hopefully we can. Let's start by picking out the slope. The slope is -3/2. That's going to mean down 3 and right 2. And this value right here, the 6, is the y-intercept. One thing I should note, when you write the slope, you do not need to write that the slope is -3/2x. We know it's the value next to x. You do not write it. The slope is just the number. So when I graph this, I start at my y-intercept, which is 6. Don't put it on your x in your x-axis. It's a y-intercept. Then from here, I'm going to go down 1, 2, 3, and right 2. Down 1, 2, 3, and right 2. Down 1, 2, 3, and right 2. Once I have a few points, I can then sketch in my line. That's an awful line. Oh, wait, I messed up. I didn't go right 2 on one of them. That's why. Down 1, 2, 3, and right 2. There we go. Down 1, 2, 3, and right 2. There we go. Now I can sketch in my line. And I've graphed it. Start at a y value of 6, down 3, right 2. I hope you would note this is the exact same equation as if it had been written as 6 minus 3 over 2x, which I think makes a little bit more sense to read off. It's saying your y-intercept is 6. It's your starting point. Then go down 3, right 2, down 3, right 2. That's why I think it's easier to learn if you write the y-intercept first. So we're going to practice a few more, then I'll have you try. This one says y equals negative 2 minus 1/2 x. The slope is the number next to the x, which is a minus 1/2. So that's going to be down 1 and right 2. The y-intercept is negative 2. So I start at negative 2. And then my slope is down 1, right 2. Down 1, right 2. Think about this. Going down 1 and right 2 would be the same as going up 1 and left 2. That would be as if I had written the slope as 1 over negative 2. That will give you the same points on the line. And if you have a few points, you can sketch the line in. Third one, it's kind of a special case. This says y equals 2x. This is actually the same as if it had been written y equals 2x, and it might not look like there's a y-intercept, but there is a number over here. It's just not written. It can't be 1, because if it was 1, we would write it. This is plus 0. So that means my slope is 2. If you want to write 2 as a fraction so that it'll help you graph the slope, it'd be 2 over 1. The y-intercept is 0. That's the number that'd be all by itself over here. So I start at 0 on my y-axis, and then I go up 1, 2, and right 1, up 1, 2, and right 1, or I could go down 2 and left 1, because negative divided by a negative is also positive. And I'd graph my line in. I don't need to make a table. Much, much quicker. Last one. It says y equals negative 3. This might not look like there's a slope, but there actually is one. It's just not written. It's because it was y equals 0x minus 3. If it was a 1 in front of the x would be written. So it must be a 0 because that's what canceled it out, which means your slope is 0. How do you write 0 as a fraction? You could write it as 0 over 1. Your y-intercept is minus 3. So you're going to start at negative 3. On your y-axis, since your slope is 0, you go up 0 and right 1, up 0, right 1, up 0, right 1. This is going to be a horizontal line. Slope of 0. And that's about all of the different types that they can do. I'm going to ask you to try now. So pull out your whiteboard. I would like you to try to graph those two equations. Y equals negative 3 halves x plus 1, and y equals x. So pause the video now for maybe a minute and a half. Unpause it once everyone's had a chance to try, and then we'll go over it. Okay, so here we go. I'll go kind of quickly because we've covered quite a few of them. The slope of this one would be negative 3 over 2, which is going to be down 3 and right 2, and the y-intercept is the value of 1. So if you're graphing it, you'd start at a y value of 1, and then you'd go down 3 and right 2. Down 1, 2, 3, and right 2. Down 1, 2, 3, and right 2. And then you'd graph it in. So there's the first one. The second one, which I'll do maybe in a green just to differentiate it. Slope is 1. That's the number in front of x. If it was 0, it wouldn't be written. And that's exactly actually what the y-intercept is. This is 1x plus 0. So your slope is 1. How do you write 1 as a fraction? Well, it's 1 over 1. So this one would start at 0 on the y-axis, which is the origin. Then it would go up 1, right 1, up 1, right 1. Up 1, right 1, up 1, right 1. And then you'd graph the line in. So this one would look like that. There you go. Last one in the note packet looks like this. This one says find the slope and y-intercept of the following function and graph it. Well, the problem with this is not written in y equals mx plus b form. This is why for 2 chapters prior we had practiced solving for y. In order to get y equals mx plus b, you need to solve for y. So we need to solve for y here. So we've got y variables, not y variable, not y variable. We need to get our y's on one side and our not y's on one side. Well, our y's are already on the left. I need to get all my not y's to the right. So I'm going to add 4x to each side. I would then get these to cancel out, so I get 2y's equals 14 plus 4x's. A common mistake I see people write is they write that's 18x's. That is not true. These are not like terms. This is 14 ones plus 4x's. So I just write 14 plus 4x's. They can't be combined. Now I need to get y all by itself. I have 2y's, so I divide everything by 2 to simplify it. And I get my equation now as y equals 7 plus 4 divided by 2 is 2. Now it's y equals mx plus b. It's technically b plus mx, but it's the same idea. My y-intercept is 7, so I start on my y-axis at 7. My slope is 2, so I would go up 2 and right 1. If I run out of space, I could also go down 2 and left 1, because a negative divided by a negative is also a positive. And then I would have my line graphed. And that is it. So if they give you an equation that is in, this is actually in standard form because x and y were on the same side. If they give you an equation in standard form, then you can graph it by solving for y and getting it into y equals mx plus b, or b plus mx, because this could have also been written as 2x plus 7. It's the same thing. That is it for this section. The homework corresponding to it I will have up here in just a second in regard to the answers. It would be day 8 on the assignment sheet, which is a graphing worksheet. So let me think if I pass that out already to you. I'm going to go look in the bin real quick. Yes, I would pass this out to you when we did the 3.3a graph by making a table. So you should already have this handed out to you. If you'd flip the page, you'll see that the worksheet for this says at the top 3.5 graph in y equals mx plus b, or x equals a number. That's a review question. So question number 6 is a review. You'll have to graph that one by just making a table. So the answers for this are right here. I will leave this video paused so that you can have the answers as you work and check them. How do you show your work? You should show your work by writing what the slope and the y-intercept are before you go graphing it. So you can't just have the lines. You show your work by writing out what the slope and the y-intercept are, just like we did here when we were doing the note packet questions. So that's what I'll check when I get back. Otherwise, here's the answers again, and then thank you very much and have a good day.